Hi everyone, this video is on exercise 13G question 6. So in this diagram, we have a curve and a line, and there are two regions, R1 and R2. So in part A, we want to find the area of R1. So region R1 is bounded by the line and the curve. So in order to find the area of region R1, we need to understand how should the integral be basically set up, because we first have the line, and we obviously need to know the points of intersection to begin with, because we are going to use them for the limits of the integration. So in order to find the points of intersection, I mean these 2 points that are here and here, we first need to set the two equations equal to each other. So x squared plus 1 is equal to 7 minus x. So we have x squared plus x minus 6 is equal to 0. Now we have x plus 3 times x minus 2 is equal to 0. So therefore, either x is equal to minus 3 or positive 2. So that means this point here has x coordinate 2. And this one has x coordinate minus 3. Okay. Now, in order to find the area of R1, we need to integrate the line between minus 3 and 2. So the integral is going to give us the area, basically the whole area here. So the area bounded between the line and the x-axis. So that's the first thing. We need to integrate the line. I mean under the line. And then in order to get R1, we need to, because integrating the equation of the line gives us the total area under the line. But obviously we only want R1. So we want to exclude this both the white and blue parts from that. So in order to do that, we also find the area of the curve, because obviously the area under the curve is going to be exactly that region that we want to exclude. So therefore, we just need to do a simple subtraction of the integral, that's 7 minus x squared plus 1 dx. So always remember, in questions like this, where you can have a single integral that includes everything because the limits are the same, you always write down the equation that gives you the total area, and then you can subtract the equation that gives you the parts that you don't want the area of. So in this case, the curve gives us the area of the regions that we don't want, so that's why we are subtracting from the total area. And the limits are minus 3 and 2. Okay, so now we can solve the integral. We have 2 minus 3, 7 minus x squared minus 1 dx. And we can simplify the integral before integrating that. So we have minus x squared minus x plus 6. Okay, now we can integrate this. So minus x squared integrates to minus 1 over 3x cubed, and then minus x integrates to minus a half x squared. 6 integrates to 6x. So we have the limits 2 and minus 3. So we substitute 2 and then subtract minus 3 substituted. And the final answer here is equal to 125 over 6. This is the area of R1. And that's the answer to part A. Okay, for part B, we want to find the area of R2 now. Okay, so this one is interesting. Because if you look at R2, we have, as you can see, kind of two parts to that, because one part of R2 is between 0 and 2, which is the area that is bounded by the curve and the x-axis. And the second part is the part that is just the area that is bounded by the line and the x-axis. So for this question, we need to find the area of the first part and the second part, and we just add them. So we don't have subtraction on like the last few examples. And it's interesting because we have two options to find the area of the second region, because we can both use the integration or just find the area of the triangle, because here a triangle is formed. So we can simply just use the formula of the triangle and just do the base times height divided by 2. So that's an alternative here. So in this case, I'm going to use the triangle part, because I'm finding the area by using the triangle formula, because so far I have been using the integration for all of these examples. Okay, so for R2, we have the first integral is between 0 and 2 for curve x squared plus 2. Sorry, x squared plus 1. Yeah. And then the second part is just finding the area of this triangle. So this triangle has a height of 5. And for the base, we just, I mean, yeah, we can say, okay, this is the base of that. And then, so for its base, what's happening here is that we need to just have the y coordinate here so we can find the difference. So in order to find the y coordinate of the point that has x coordinate 2, we just substitute that into this, and we have 2x squared plus 1, which is 5. So here is 5, its y coordinate is basically 5, so the difference is simply equal to, I mean, sorry, yeah, the base is also 5, so the height is 5, the base is 5, so the area is this. So the area of the triangle is a half times 5 times 5, and yeah, so this allows us to find the area of R2. So x squared again integrates to 1 over 3x cubed, and then we have x 0 plus 25 over 2. And yeah, so we just substitute and add them, and finally we get 103 over 6. And that's the area of R2.